Good day, everyone. In this presentation, we're going to have some more knowledge about polynomials. We're going to know what they are, and we're going to know all these things. I know you guys, you are new to doing things with the video, but the biggest strategy I want you to do is pause and walk out the videos as we work out the problems. All right? And that's going to help you guys a lot. All right, so today's learning objective. You want to define a polynomial. We're going to review long division polynomial, and we're going to be introduced to the zero remainder theorem. Now, I'm going to read stuff to you, but I'm going to make it short and to the point. All right, so it's just some reminders and updates. You guys make sure when you do the homework, you do it by hand. Make sure you do not commit academic dishonesty. Don't do it. Please don't. Everything gotta come from you. I gotta help you. I gotta see what you got. Phones needs to be in the pocket. If seen or caught, I'm gonna ask you for it and you choose not to do it, of course you already know the policies from there. At the end of the month, you guys have a big quiz at the end of the month. Unless you have an excuse, you will not be given makeup work when you are absent. So please, y'all be here because I want to do it. Let's talk about the important definition. So we're going to say just a definition. It is very important, and every class period we are going to write it down. I want y'all to do it. All right. So you are in this definition of mathematics. It's called the precise definition of mathematics. This definition describes what mathematics is truly about. All right. What it truly means, what it's all about. The technique, mathematics is the technique to explain, understand, and manage reality by ciphering, counting, measuring, classifying, ordering, inferring, and modeling patterns arising in the environment. So it doesn't matter what goes on. This is the precise definition of mathematics. It's very precise. It's to the point. This is what mathematics is all about. You know. So when you say I ain't gonna ever use this in real life, sadly you are completely wrong. But it's not gonna be in ways that you think, however. So keep that in mind too. And you will see this definition on your quiz, so you make sure that you know all of it. All right, there are two types of math in this world. In every math course, my course, some other course, it doesn't matter what course, it's two types of math. You have abstract math, you have applied mathematics. So, like going back to your geometry, you dealt with proofs, you dealt with definitions, facts, all that stuff. What it did for you, it helps you to, think logically. Helps you think logically. All right. The next part of mathematics is being applied. Applied means that you can apply it to real life. Polynomials, I promise you, you guys are going to see this in real life. You're going to see it soon, and you're going to see how it works in real life. Throwing objects, so that's me if you're kicking a football or goal, all this, all that. Money, health, it's just doing stuff. All right. So what is a polynomial? A polynomials are an algebraic expression that consists of variables and coefficients. Variables are sometimes called intermediates, indeterminates. All right. Polynomial comes from poly, meaning, and normal means term. So it says many terms. However, you could have a single term called a monomial. So you're going to see exactly what all this means. And of course, this is something that you have to know on your quiz. So all a polynomial is really saying is just, as long as it has a positive exponent, like x by itself is a polynomial. Although it is called a monomial because it's a single term. All right? So here, at this example, this is a polynomial because you got 1, 2, 3, 4. You have more than 3 terms, so therefore it's a polynomial. All right? This -3, I want to talk to you guys about. That -3 is also a polynomial because -3, and I'm sorry about how this is rewritten, -3 could be rewritten as -3 x to the power of 0. And we know anything to the power of 0 is going to be just 1. So it's going to be -3 times 1, which we know when we multiply that is going to be -3. I need for you to be able to explain that piece. All right? What's not a polynomial, you cannot have a negative exponent. It has to be exponents of 0 and above. So you cannot have a -1. Any negative exponents not allowed. Your exponents cannot be written in the denominator of a fraction, in which which we will know that we have another name for fractions that we use in higher level mathematics. All right? So far, we just did definitions and facts. All right, so look, these are examples of polynomials. So this one term right here, this is a monomial because it's a single term, and it is a polynomial because, again, x by itself has an exponent of 1. And again, I'm doing this with my mouse, so be nice. I'm writing with my mouse, so, I'm not, that's the only way I can write. So, this 5x, again, that is a monomial because it has an exponent of 1. All right, this 2x plus 3, that's a binomial because it has 3 terms. And do not forget, 3 can be rewritten as 3x to the power of 0, which we know anything to the power of 0 is going to be 1. So it's going to be 3 times 1, which gives me 3. That is how we get our answer. That is how any number you could think of. And the same thing could happen from 5, 10, 100, 1,000. 1,000 could be rewritten as what we just did here. So 1,000 could be rewritten, a million, a gazillion, all that could be rewritten as the same thing. All right? So x squared plus 5x plus 3, that's a trinomial. So let's look at 6. A 6 is a polynomial because 6 could be rewritten as 6x to the power of 0. And we know anything to the power of 0 is 1. So your answer is going to be just 6. And we know this last term is polynomial because there's more than 3 terms. And again, 6 could be rewritten as x to the power 0. Therefore, it is a polynomial because do not forget that as long as the exponent is at least 0, which we know anything to the power 0 is 1, it is a polynomial. But this is just that. So here's a special note. You see how 5 is a monomial? 5, the single digit 5, is called a constant. You hear me? 5 is a monomial called a constant. Because what we just said, 5 to any power, 5 to the power 0, which we know anything to the power 0 is always forevermore 1. Alright? So it's 5 times 1 equals 5. This is a important piece of information. Please write this down, alright? You are responsible of knowing just that. Alright. So we discussed how this could be rewritten as a division problem. We know that the denominator becomes the divisor and the numerator becomes the dividend. Our answer to the division problem is called a quotient, and then what's left is called the remainder. These are things that we know already, and this is what we talked about in class today. And I do need for you guys to know set information. Alright, in class, we have worked out this long division problem. One of the things that I want to caution you all to do is when you go home, I'll post the Kahoots and Google Classroom for your additional practice. We've been over this for 3 days, so I can't go over this no more. We practice. Now we gotta move on to other things. All right? What's going to make this course a little bit challenging is that we're going to have to move a little bit quicker through certain things. So I'm really going to need for you guys to really get with the program here. So with that said, let's get back to this long division problem. So what I want you to do, I want you to pause and work this out. If you have your notes from today, great. Work it again and just see, do you understand the steps? I want you to do this for the first 2 procedures, all right? Because we know the dividend has the biggest exponent of 3. That's telling you how many times you're going to go through the process, which is 3 times. So pause the video and just see what you can do. All right. I hope you paused the video. If you have not, please pause the video and work the problem out. Once you have finished working out the problem, just resume and let's see what you got. If you have done so, let's move on. So we know when we did the first step, we know that we got the quotient to be x squared. When we did this, because we know that x cubed, you always divide your biggest exponent in the dividend. Always the biggest exponent in the dividend by your variable in the divisor. So it's always going to be x cubed divided by x, and we know when you divide exponents, it's going to be subtraction. So 3 minus 1, when you subtract, you're going to get x to the power 2. That's where that comes from. All right. And then from there, You got to do your multiplication, which we know when we multiply, we got to this step. That's what we know. Because we multiply x squared times x minus 2. And when we multiply all this, we get x cubed minus 2x. That's what we got for the multiplication step. Now when you do your subtraction, we know that we have to take the inverse of what we got for multiplication, which is right here. So this is the multiplication step, and now we just turn it into the subtraction step, so taking the inverse of everything. So negative x, positive 2. And when you do all this, you're going to get this guy right here. So this right here, this is all a repeat of what I just did right here. So I'm going to erase this. This is the repeat of all the things that I did right here. So what I just erased is a repeat of all the things that I did right here. All right. So that's the first process. I know because in the dividend, the biggest exponent is 3. I had to do that 3 times. So that's once. So why don't you try to do it 2 more times by yourself, and once you're done, pause the video and see what's up. Okay, by now you should have finished that problem in its entirety. If you have done so, let's see your work. If you have not done so, please, pretty please, pause the video and actually do the work. So this is what we got. We got the quotient to be 6x. And let's explain this. So over here, this is my new dividend. Again, you always divide the biggest exponent in the dividend, which is x to the power of 2, divided by the variable in the divisor. So 6, let me write this over again. 6x squared divided by x. When you do the division, you're going to get just 6x. Again, just for a reminder, because I'm doing this with a mouse on my laptop, that's the reason why my handwriting looks the way it does. So, alright, so that's how we got a quotient. And then this 6x minus 12, you know, that's the multiplication. And then when we do our subtraction, we realize that it becomes, negative 6x becomes positive. I'm sorry, I'm tripping. Let me rewind and pause that back. So, I'm actually going to do this step with you, just to make sure that we're all on the same page. So, when you multiply 6x times x minus 2, and we multiply this, our answer is going to be 6x squared minus 12x. So that's where this comes from. When we do our inverse, our subtraction part, 6x is going to become negative 6. So that's what this negative 6 comes from right here. So this negative 12 is going to become a positive 12. So the 6 cancel out. Negative 5 plus 12 is 7. And then I just bring down to 14. All right? So far, so good? Great. All right. Moving on. All right. And this should be our last step. because we are right here. I'm sorry, we are right here. So when we do this and go through our procedures, we get 0. So just for a reminder, when we divide, we went with 7x divided by x. And this is going to equal 7. All right. And the multiplication, which we know, 7 times x minus 2. And just for a reminder, again, I'm doing this with a keyboard on a mouse, so you have to forgive the sloppiness on that, but it is very legible. So everybody can see that to be a 7. And when you multiply this across, you get 7x minus 14, which we know we just got to take the inverse of that. And when we do that, it's going to be negative 7. And then this is going to become positive 14 because we had negative 14 becomes positive. So when this cancels out, our remainder becomes 0. All right? Now, we did enough review. Now let's move on and do something new. So what if I was to tell you that you do not have to do that long division process to get the remainder? What if I could tell you something easy that it could become easier? So let's look at this remainder theorem. If p of x is a polynomial of a degree 1 or greater and c is a real number, when p of x is divided by x minus c, then the remainder is p of c. So this is just for you to just know, just to write it down and to just state it. But I'm going to show you what it truly means. So this is the definition that I really want you to know. I want you to know this piece of information more than that definition. So if p of c is equal to 0, then the remainder of the theorem tells us that if p is divided by x minus c, then the remainder will be 0, which means that x minus c is a factor of p. Next week, you're going to know about factoring. So let's get on through it. So before I continue, let me just tell you this. If your remainder is 0, just like we just did in that previous division problem, it's factorable. I mean, it's a factor. That's all you have to say. It is a factor. All right? So let's do it. For example, this problem. You're going to see what I'm telling you. So that x minus 2, you're going to turn that to an equation. And we saw the equation is going to be 2. So all I'm telling you to do is change negative 2 to positive 2. Then I want you to take what's in front of the dividend. I want you to plug in 2 for every x you see. So when you plug in every x you see, you're going to get 0. And when you get the answer 0, it is a factor. So it is a factor because your remainder is 0. When you guys do the homework, make sure you do these kind of problems. Do these kind of problems. Do these kind of problems. I know there's some of the homework where you just gonna have to leave blank, and I'm cool with that, but you cannot leave these type of problems blank. All right? So let's do another example. And again, all the remainder theorem says that if it's zero, if the remainder is zero, it's a factor. So we're going to do the same thing as we did before. So you see the x minus 3? Why don't you pause the video and do what we just did? See what you can do on your own. Pause the video. Alright, by now, you should have worked this problem out already. If you have not done so, please, 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 pause the video again and just do the problem. Because otherwise you're cheating yourself. And again, you gotta know how to do the stuff. Alright, so let's do it. So, did you turn negative 3 to positive 3? And did you plug 3 into every x you saw for the divisor? And did you get 118? If you got 118, kudos. You is all of that and a bag of chips and a drink on the side. And because it's 118, it is not a factor because your remainder has to be 0. So x minus 3 is not a factor. Yeah, I'm doing it so hard with the mouse. I'm struggling through here. All right. So it's not a factor. So therefore, it's just not a factor because the remainder is not 0. Remember, your remainder has to be 0. All right. Just for fun, I want you to do this one on your own, just like we did in the other two, and see does n minus 5 is a factor. I'm not posting the answer on this one. I just want you to try it. All right? And you could just do this yourself, and you should be able to find out. All right. That should do it.